last video of Lab 1 tutorials, I'm just going to say a couple things up front, and then we'll talk about more quantitatively comparing this rainfall data, whether we do that across our interpolation or at individual points. Beyond that, also with your visual comparisons, right? You can make map outputs of this. And so you'll want to generate some cartographic outputs. And so you'll have to look up how to do that if you've forgotten how. I'm not going to make a video tutorial on that right now. But yeah, you'll want to basically insert a new kind of layout, right? And then create some map outputs that you'll upload and visually compare those things. Okay, so how do we quantitatively compare? Okay, so we can do a number of different things. So we've got these two IDW outputs. We ran them as similarly as we could, right? We used all the same parameters. They won't be the same for a number of reasons. One is the rainfall was different because one is the Utah normals over 30 years and one is year 2021 only. So if that difference is totally related to that, that's exactly what we want to know, is how different they are. But there's other reasons that they're going to be different as well. Remember that their stations weren't always in the same exact position. They don't all fully overlap. But nevertheless, there's some ways that we can quantitatively compare them. We can go to analysis, we can go to tools, we can go to in spatial analyst tools, there's a tool called raster calculator under map algebra. And we should be able to say compare 2021 and subtract it from the normal. So if it's more rain in 2021, it would be higher. If it's less, it would be low. If it was less rain, then this value will become negative. But it only works if the rasters are, I think, in the same exact location. We may choose environments, so we maybe need to say minimum of inputs. So like where they just overlap, basically. So hopefully that math will work, but let's see. So we'll call this one, and I'm not going to give it a file extension because I'm working in this GeoG database. I'll just leave it as a default Esri grid. So it's like, so it's IDW 21. I'm going to do dash norm. So 21 minus the norm run. That's not happy with that. Might not like the dash. And do underscore. Yeah, I think it likes that. Okay. Yeah, so that ran. And so it shows positive and negative areas of positivity and negativity. So where 2021 was more precipitation than usual and less, it looks like huge amounts, but I bet if we to hone in on that a bit more, it wouldn't be so much. So if we were to say, instead of stretching it, we classified it, and then we did look at the histogram, you can see that most of the values are very close, much closer to 0 than they are in these extremes. So let's put our high classification here. I don't know, let's say it's where it's more than, I don't know, 10. Okay, fine. We'll do one with 10. We want one of these at 0. Well, I guess we could do natural breaks. Let's see what that gives us. So but I don't like the color scheme. We want kind of a negative and a positive. Okay, so I've changed it up. So here's what we're gonna do. Maybe that's too many. 10 classes. Why don't we go down to like, I don't know, 8? Okay. So if we go to 8 classes here, we can get, you know, different break values. We can say, let's find. We should be able to change these exactly. Not edit the break value. Yes. So I can change it to -2, right? So things below -2. Here I could do change the break value -0.5. And here I'm going to make this break value be 0. And then the next one, I'm going to make it, be very simplistic. I'm going to have it be 0.5 positive. And then I'll make this one 2. And then I guess I've got a few extra here, right? So I'm going to edit this one to -5. But didn't like that, did it? Don't let me go that way. Okay. Well, we won't do that. Okay. So I guess there's more that are positive. So let's just do more that way then. Okay, so we'll do this one as +5. No, I'm going to move this one first. Edit. We'll move this to 10. And we'll move this one to 5. Okay, so then positive is red and negative is the yellows here. We can change that later. So if we go to classes here now, we could make negative be kind of blue, and then lighter blue, and then this could be kind of neutral, like I don't know, a green, because it's near 0. Oh, well, that was also negative. Actually, it should still be a blue. And then these are orange to reds. So it's very contrasting, right? So we can see quantitatively where things were uh, either less rain in 2021 or more rain in 2021 than the long-term average. Okay, and so we can see it's, according to this interpolation anyways, it's kind of spotty around the state. So that's one quantitative way to go, by differencing the output grids from the interpolation. Okay, so that's one way to be quantitative on the grids, doing a interpolation and then doing your raster math on those grids, and then classifying them with negative and positive values and seeing where it's above or below normal. And you could do some sort of summaries if you wanted to get into more details. That could be continuous over the landscape. On average, what are the pixel values, positive or negative? But that's like pushing it, right? Because it is an interpolation. Now, what about on the actual values themselves? So, how many of those stations really overlapped is a good question too. So one thing we could do is if you pull up your Utah normals, I'm going to first turn off all these other things. So the normals feature class here is shown with these little waypoints of blue. They have station names and and everything. And so the stations should be something we could like join tables by, right? And so I want us to try to do that. So we could do a table join. So we can right click on this and say joins and relates, add join. And so the join field is going to be the station. And then we want to bring in we want to join that with Utah rain 2021 normal and see what happens. So yeah, now we brought in all our 2021 data, and yeah, we can see that, you know, wherever we've got them coming through, it worked. This didn't work for all. We have some nulls, but that worked pretty well, right? Okay, so then you know, basically what you've got here now is you've got annual precip here, 21.12 on average for Alpine Utah. You can see what it was in 21. It was 18.52. So that's pretty cool. If I go data, export features, and I call this Utah normal underscore 21, I'm going to try to make a new feature class that has this data appended to it. Whenever you make a join, the joins are temporary. But if you export that to a new feature class, it becomes permanent. Let's see if that worked. So open up the attribute table of that. Yeah, it became permanent. Good. Okay, so I'm going to go back to the other one, though. And I'm going to see if I can push this join some more. So I'm going to right click on it. I'm going to say make another join. I'm going to add a join. And this time I'm going to, you know, the station again. But the join table is going to be from 2022 and station. I say, okay. It should get further down the line here. And should have 22, yep. And we have some more nulls now. But yeah, it seems to have brought everything in. So now I could right click again and I could say data export features, and we could call it Utah normal and 21 and 22 data. And I'll add that. Okay, so I'm going to open that attribute table. And it's got everything in it. Okay, it's got too much stuff, right? But it shows it worked. Okay. Now, things could get a little confusing, right? Because I'm going to want to do some math here now. But like this precip here, I'm going to tell it apart from that precip. I got to be pretty careful. I'm going to add a field though, and I'll try to be careful. But we could edit those too, I think. Okay, cool. So one says precip, the other says precip underscore 1. Perfect. Okay, so this one I'm gonna call we're gonna call it 22. No, we're gonna call it y22 underscore norm. And it should be float. And yeah. Well, I mean those are all doubles, so I guess I'll stick with double. Okay, save. So I added a new field. And the reason for that is I can then go over here and see that new field, and I can do calculate field. And I can say that it basically Utah's year 2022 minus the normal is what I'm going after here. So what I want to say is that it equals precip from 2022, which is the last one here, minus, oops, I got two minuses there. So minus the normal precip, which is this annual precip normal. That's pretty easy. And I'm going to say, okay. It didn't work for all because of nulls. That's the way it should be. But it should, which ones didn't it work? So those ones. Okay, so, but you can see which ones were negative and positive. Let's see, so we can sort ascending maybe. So the first is nulls. There's a lot where 2022 is less than normal. But there should be some maybe where it's positive, yes. But generally, year 2022 minus normals was negative. So sort descending, maybe that'll look a little bit more interesting. So you could even do statistics on that. So from the stats, we can see that on average, it was a couple of inches below normal precip in year 2022. Now that's interesting, right? Because that goes to one of the final questions in your lab. Is how is it the year 2022 is below normal when we think of that as an overall wet year, and we need to go back to what is the annual year versus the water year. Okay, so you can do this same thing, right? For so you could save this graphically. You could you could color these features according to that value that you just calculated to show where it was above and below normal. That would be another way to quantitatively and visually compare this. We can do this same sort of math on the 2021 data as well. You could compare it to the 2021 to the normals, or 22 and 21. How did they compare? I'll leave that up to you. So you can make your own new fields, do the math, and then display it. Okay, so that would be one way to be a bit more quantitative about this. So I'll stop this video here.